Another thing about evolution is evolutionists talk about coevolution. Coevolution, it's like the flowering plants are fertilized by bees, for example, or what other insect there is. And they evolve together in order to have this symbiotic relationship. Excuse me, what if the bee came a couple of million years too late? What would happen then? They would have to be there at exactly the same time. So I wouldn't call that coevolution, I'd call it interdependence. And once you start going into the interdependence business, it becomes very fascinating. Because everything is designed to give in order to receive. Now just think about that. Everything in this world is designed to give in order to receive. No matter what cycle we look at, whether we look at the oxygen cycle in the world, where the oxygen is necessary for us to breathe, and we breathe out a terrible gas that is banned called carbon dioxide. And the plant says, "Thank you," and absorbs it for you and gives you oxygen in exchange. And it's a terrible fact that our carbon dioxide level is 0.04% at the moment. And in the 1800s, it was only 0.04%. So it increased whoppingly from 0.04 to 0.04 in our time. No wonder Clifford Goldstein talked about lies and more lies. Do you know that the Bible says that? The Bible says, surely we have inherited lies. And I can vouch for it that I believe we have inherited lies. So this hummingbird that can fertilize these plants and receives its nectar in exchange, how long did it take to evolve this system that no helicopter has been able to emulate? And fusions. You can get rearrangements under certain circumstances where chromosomes, which are of different shapes and sizes, can come together and fuse together. So, for example, certain wolf species have 76 chromosomes. And certain wild dog species and coyotes and etc. have only about 40-something chromosomes. But when you look at the 40, they're long chromosomes, and you look at the 76, they're shorter chromosomes. So all that happened was they fused together, which means that you get rearrangements of the genetic system with the identical information in another sequence. Let me give you an example. Here on the stage is an instrument that lady plays with perfection. It's called a piano, right? And it has a whole lot of genes, some of them black and some of them white. And they have activators. It's called her fingers. And she can activate those genes by running her fingers across the genes on this piano, and she can produce a tune, which I could never do. My wife can, but mine would be a disaster. So there she goes, and she plays on this piano. How many tunes can she play on that piano? Unlimited? You sure? I think so. Unlimited. That's better than a computer. Did you know that? Yes, because you only get a gig or 10 gigs or a terabyte or a gigabyte or whatever, but this is unlimited, right? Your brain, when is it full? When does it say, disk full?
It's for everything that you ever want to do or be. Your brain.
It's never full?
Oh, no, it's never full.
Never full. But then you're better than a computer.
Yeah. But
I want you to think about that.
we only use a small portion.
That's besides the point, yeah. All right, so how many tunes can you play upon that piano? So let's say that piano there is a piano, and I put another piano over here that looks different, like an upright piano. It would still be a piano, right? Or a honky-tonk piano. The sound would be different, but it would still be a piano, and it still need the same mechanism, right? That's how your genes work. So how many varieties of tunes can you play with that genetic system? Unlimited. How many varieties of dogs with different characteristics can you produce with that piano, if it were the genetic system of the dog? Unlimited. Or the human being. I mean, we're now sitting at 8 to 9 billion people and everyone looks different. Isn't that weird? That's why I can say to Alden Ho, "Hi, Alden," and not, "Who are you?" amongst the millions that are exactly the same.